In this video, we show how to apply the computational rules for logarithms of complex numbers. Consider the complex numbers, written in polar form. Z equals 5 times e to the power of negative 3 pi over 4 times I. And W equals 2 times e to the power of pi over 3 times I. We want to calculate the logarithm of z plus the logarithm of w. Let us first look at the theory. Consider two complex numbers, z and w, and a natural number n. The logarithm of z times w is equal to the logarithm of z plus the logarithm of w. Applying this rule to the example, we get the logarithm of 5 times e to the power of negative 3 pi over 4 times I, times 2 times e to the power of pi over 3 times I. Multiplying the magnitudes and adding the arguments, we obtain the logarithm of 10 times e to the power of negative 5 pi over 12 times I. Using the definition of the complex logarithm, this becomes the logarithm of 10 minus 5 pi over 12 times I. Now, let us calculate the logarithm of z to the power of 3. According to the theory, the logarithm of z to the power of n is equal to n times the logarithm of z. Back to the example, we get 3 times the logarithm of 5e to the power of negative 3 pi over 4 times I. Using the definition of the complex logarithm, we obtain 3 times the logarithm of 5 minus 9 pi over 4 times I, where we multiplied the exponent by 3. Finally, let us calculate the logarithm of e to the power of z. We use the rule that the logarithm and the exponential function cancel each other. Therefore, we get 5 times e to the power of negative 3 pi over 4 times I. We can also show that e to the power of the logarithm of z is equal to z. Using the rule again, we get 5 times e to the power of negative 3 pi over 4 times I. This concludes the examples. Thanks for watching.